Okay, so since I'm not here, I'm just going to do a few examples of ordinary annuities, and then the supply is going to put up the rest of the solution so that you can give it a try on your own. So to start with, we have to do a recall, and remember that an annuity is a series of regular payments. So I want you guys to fill that in. Regular payments. And it's made at regular intervals. So you have to remember that it's not a payment here and there, it's actually a regular payment. So every month or every week, as long as it's regular intervals, you know that it's an annuity. Okay? Usually we have a present value and we want to know how much money we will have in the future, but sometimes we want the money in the future and we have to figure out how much to invest or borrow right now or in the present. So you're used to having formulas. Here's the formula for the present value. The hard part is knowing which formula to use when. So just remember that when you have the final value, when you have that amount in the future, you would use this one, sorry. When you don't have that future value, you would use the other formula that we learned, I believe, on Friday. So we're just going to define a few things. Here, P represents present amount or present value. There's a couple different ways of identifying this P value. Just know that this P value is in dollars. The R represents the payment amount. So we saw this last week. R is a new variable, and it represents the payment amount. And this would also be in dollars. The I is the interest rate. Remember that the interest rate is given in percentage. However, you're going to need to convert it to a decimal. And there's an extra little thing that we have to do with interest rate and the N value, but we'll discuss that in a second. And N represents the number of payments. So it's really important to know that N represents the number of payments and does not represent the number of years. So we still need to find the N value, or what we call the compounding period. That's something that we always want to pay attention to because the interest rate is given for 1 year. And again, the banks don't give loans or investments at a certain percentage 12 times a year. So they have to split up that interest rate. And when we split it up, the I value is impacted, so that means we have to divide it. So the I value is divided. But then that T value that I tell you to kind of ignore, we're going to fill it in here just because it's in the note here. But once we do the actual question, I'll let you know what I need to see. So that's the length of the term, just one term, and that is in years. And that impacts the N value, and as the N value will be multiplied by the compounding period. Okay? So I like getting into this kind of stuff because it becomes a little easier to work with rather than all these words that you're not really expected to memorize, but just to kind of understand so you can read through them again and just understand the concepts. So Darwin makes quarterly payments at $650 at 4% compounded quarterly. So there's a couple things that are really important here. I like to always attack the compounding period first. I like to see the number of years and how the payments are made. So if it's quarterly payments of $650, I can start filling in the R value because I know that the payments are going to be $650. And the amount of the payment is your R variable. So he's making quarterly payments at 4%. So I'm going to go ahead and do the interest rate. You should all know now that 4% divided by 100 is 0.04. And don't forget that you have to divide this interest rate by the compounding period. And in this case, the compounding period is quarterly, so you have to divide it by 4. So if you just divide it by 4, you're going to get 0.01. Okay, so that's the I value that we want to use. We also want to use the N value of 5 years, but it's not just 5 payments. She makes payments 4 times a year. So in 1 year, there's 4 payments, and in 4 years, you just have to multiply by 4 to get 20. I don't want you to take care of that T or the N, so you can just scratch those out, and you could put a question mark for the P, because that's what we're looking for. So I'm going to go ahead and skip down to the sample problems. I'm going to skip down to example 1, and we'll do example 2, and then you can fill in the rest with the note that is supplied. So, for example 1, we have Dennis that has to start repaying his student loan. That might be you guys in a few years, not that long from here. So his monthly loan payments are $200, and they're going to be withdrawn from an account earning 6% interest compounded monthly. So there's already quite a bit of information here. So payments of $200 is important, 6% interest, and I'd say compounded monthly is pretty important. How much must he deposit in the account today? That won't always be there. You may not always know that this is a present value question, but because it says how much does he need to put today, that means that we're looking for the present value and not the future value. So he's making regular payments of $200. So that $200 is going to go where the R is. If you look up in the note, it explains that R is the amount of payments. We're going to not worry about N and T. The I is the interest rate. So the interest rate here is 0.06. I got that by dividing by 100. But it's not 6% 12 times. You have to remember that we need to divide this by 12, and that will give us 0.05. Be careful, 0.005. So you want to make sure you put all those zeros in, otherwise it'll impact your answer. So the interest rate is taken care of. I want to know how many payments he's making. So his monthly loan payments of $200. How much money does he deposit in the account today? For 1 year. There it is. Okay, if it's for 1 year and it's compounded monthly, he's actually making 12 payments. Okay, once you've got your variables, it's actually just a matter of subbing some stuff in. So we're going to write the formula down. P equals R square bracket 1 minus 1 plus I. Don't forget the negative with the N this time. And then we divide the whole thing by the interest rate. So we just start filling in some stuff. R is 200. Keep the square bracket, 1 minus. At this point, I like to do 1 plus 0.005, which is 1.005. So that shouldn't be too much of a hard time.
Please. Just a reminder.
Okay, so typing this into the calculator is kind of an issue. So I'm going to go ahead and pull that up and show you how to do that. And I'd really like for you guys to have a calculator before you start this. To type this into the calculator, you're going to want to make sure that you know how to type this in, because you're going to get the wrong answer if you don't. So we're going to type in 200, open up a bracket for the square bracket, 1 minus 1.005, close that bracket. Oops, I forgot a bracket. So, sorry, I got to go back. It's 1 minus, open up a new bracket, 1.005. So that's for the interest rate. So the interest rate kind of gets its own bracket. Make sure that you put to the power of negative 12, not to the power of minus 12. So then I need to close the second bracket, and don't forget to press enter. So you should get 11.6 at the top, and from there, now you could go ahead and divide by 0.005. If you need to review these steps, this video will be in OneNote, so you can review it on your own. So hopefully you're giving this a try, because I'm going to be quizzing you guys on this probably tomorrow after I'm done reviewing it with you. So that's $23.23, so $2,323.8. However, we need to make sure that this is money and is represented by 80. Okay, I think my calculator actually is in float, or 1. So you want to make sure your calculator is in float, because the rounding I think is a bit funny. Yeah, so if you do this again, 200, 1 minus So I'm just giving this a try to show you that when you have your calculator on a different rounding mode, it's going to make a difference for the decimals. So if you see here, it's actually 79 cents. It's not 80 cents. And I know that it doesn't seem to make much of a difference, but you should be used to putting your calculator in float mode anyways. So float, you go to mode, and as you can see, float is highlighted. So just make sure that that's happening when you're doing this work. So again, a little concluding sentence here. Therefore, Dennis must deposit $2,323.79. And because we rounded, I want the words about or approximately. So that's exactly what I'm looking for here. Okay. So you guys can go ahead and try the next ones on your own and see how that goes. Again, the supply is going to show you the solutions so you can fill them in. And if you have any questions tomorrow when I get back, we can go over this. And I'll show you how to use the graphing calculator real quick for the TVM solver. So if we go to the TVM solver, we're going to press apps and then enter. The N value in the TVM solver, and I really want you to be careful, it represents the number of years, okay? Or number of payments, sorry. So you really need to be careful because when we were not dealing with annuities, it was number of years, but now that we are dealing with annuities, it's the number of payments. Okay, so the number of payments would be equal to 12 in this case. The interest rate will be 6%. Remember that in the graphing calculator, you don't convert to a percentage, or sorry, to a decimal, you just keep it as a percentage. So your I percentage is 6. Your present value, since you're looking for it, will be 0, but eventually we're going to find an answer for that. We do have to fill in the payment since these guys are doing $200 payments. Your future value will also be set to 0, okay? Because he's paying off the loan. So at the end of the loan, you want to make sure that your final amount is 0. Your payments per year is 12, because there's 12 payments per year, because your compounding period is 12 months per year. So make sure that the end button is highlighted here, okay, when you do that. So this is what it looks like when you have it up here. So you can just double check with my calculator to make sure you have the right amount. And since we are looking for present value, we go up to present value and we press alpha solve. So we get 23 and 79 cents over here. And there is a negative in front. That's just because he's paying this amount at the beginning and he doesn't have access to this money. So again, make sure you practice using the calculator, make sure you practice putting in the proper values, and the supply will put up the completed notes so you guys can finish this up.